Okay, so today we'll talk about smart contract security. I will read a bit the room to understand what kind of, like if I can go really technical or if I should start from the ground up. So who of you doesn't think themselves as technical, so you don't work in Web3? Okay. Okay, so something like business. Okay. So who works in Web 2, not in Web 3, but in a technical role? No one? Perfect. Who works in Web 3 in a technical role? Okay, perfect. So I work at Hacken. I'm a Solidity smart contract developer. Not developer, auditor. Those are few information about me. The most important part is that I've been here since 2013 and I've seen a lot of hacks, thefts, loss of keys, loss of money that could have been prevented, and doing stuff that I will talk about now could like help for the future to prevent those kinds of problems. So with smart contract, every transaction is a financial operation. So every time you do a transaction, you are moving funds. They either are fungible, like ERC20 tokens, or they're non-fungible, like NFTs. But every time you write something on the blockchain, is very connected to a financial transaction. So if you are interacting with a smart contract that is not secure, you will lose your money. So in smart contract development, it's very important to have a complex approach and put security before everything. So most of the time in Web 2, we think that user experience probably is better than security in some areas. In smart contract development, security should be the main priority. So it should always come before user experience or any other kind of sector. It should be the main point, because if you get it wrong, you will get hacked. So we will talk about a few of the best practices that you can put in place, both before the deployment and after the deployment. So these slides are done in a way that if you're listening to it, you should be the Web3 project that is actually writing the code. You can actually view them as, if you want to see if a project is secure, you can see if the project has those kinds of areas. So if they have external reviews like audits, if they have documentation, if they have how their code is structured, how the documentation is structured. So you could see the slides also from the point of view of a user that want to understand if a project is secure or not. So those are the most common best security practices that should be used. Probably the most important one that gets a bit ignored is having functional and technical requirements that are very defined, very well defined, and that everybody in the team knows about it. So functional requirements are what you're building, technical requirements are how you're building it. So they're like your compass, they're like your map to understand how to navigate and how to build and deploy your project. So it's very important to have a compass to understand where you're going, so to have what you're building and how you're building it. Should also be used test-driven development. We'll talk about what it is later. It should be set up automated workflows, use analysis tool. Of course, the smart contract should be secured. So we will see a few kind of attack that can happen in smart contracts. They are very different and sometimes they can be very hard to spot. So that's why you can have external reviews. So guys like us at Hacken, we can look at the code and understand if everything is right, because our job is to look at vulnerability, identify them, and solve them. So sometimes having the smart contract secure might be very hard for a developer, so it's important also to have external reviews. And of course, the smart contract should also comply to what are the functional and technical requirements, because if not, you have a compass, but you actually don't know where you're going. So let's talk about the requirements. So you have different ways of specifying and identify the requirements. So you have NatSpec, user story, tokenomics. So you should use different techniques to understand what are your requirements, and you should express them in different ways. So NatSpec is a kind of comment that there is in the code. So for the developer, that might be very easy to understand, but for other users, might be not. So tokenomics and user stories are other ways to communicate to different kinds of people. You should do threat modeling. So from your requirements, you should understand where does the hack can come from. So let's do an example. You're building a bridge. For how it is structured now, the EVM and Solidity, it's very hard to do a bridge right now that is not centralized. So you have to have some part of the bridge that is centralized. And since you have a central part, you can understand the threat in the fact that if they get the private key or the multisig that is responsible for signing the transaction, they can drain the bridge. So this is one of the threats. You can identify this risk. You can see their controls. You can see how to avoid it. So you can see all the ways of keeping your private key in a secure manner. But there are hundreds of risks. So they can come from an interaction, smart contract, Web 2. There is a lot of risk, and they should all be treated in the right way to avoid them. So after that, you should prepare a user documentation, not only for the users, but also for the auditors. It will help a lot when they are actually doing the audit. So you should do tutorials on how to use the protocol, run scripts, installation, docs, FAQ, and everything that can actually help users and auditor to understand and read the code. So if you don't do requirements, your project can be anything, because you don't have a map. You can go anywhere because you don't know what you're building, so you can actually, it's very flexible because you can be anything. Also, you're not afraid of the complexity because there is no complexity, because you don't know what you're building, so you don't know what the complexity will be. And so if you define actually the requirements, the complexity is there. So it can be scary at first, but it's actually cheaper, faster, and more secure to develop something with the requirements. And I'm biased on this, but the auditor will actually love you for the requirements, because sometimes when I audit projects and they don't have requirements, 80% of the audit is spent to understand what is actually written and what should be done. So I lose 80% of the audit in trying to understand what should have been explained, because that was the documentation, that was the code readability, that is not there. So sometimes if it's really bad cases where there is no documentation, no readability of the code, most of the audit is spent in trying to understand what is actually going on. And so it's very important to have requirements. So how to write requirements? You should define high-level requirements. So I have a few of the biggest one that you identify. Decompose them, so arrive to the root of the problem, so low-level requirements, describe each math formula. Math can be fun, but not if it's not explained. Sometimes there are very complex math formulas that are not explained, and that's very dangerous. You should estimate possible loads, so this is mostly for your Web 2 system, so your website. But can also be for edge cases for your smart contract. You should prepare technical specs based on the workloads, communicate them with your team, so everybody on the team should actually know what is going on. And one of the most important parts is that you should adapt your requirements, because requirements can and should change with time, because they can adapt to the evolving space, so they should change with the space. So the question sometimes is this even about security? Yeah, every time that an hack happens, it's because a requirement is either flawed or its implementation is flawed. So if you cover the requirements and implementation, sometimes hack can still happen because we might not know that there exists a vulnerability, so we might not look for that. But still, most of the hacks happen because the requirements are either flawed or the implementation is flawed. So yeah, this is about security because, as I said at the beginning, every transaction in crypto is a financial transaction. So if your project allows for transactions that are flawed, this is about security because you need to protect your funds. So to do it, test-driven development might be the best weapon for developers. So let's follow the flow. So you are here, you have your requirements, you have written high-level requirements, decompose them, you know them, you adapted them. You go into development. So you read them, you understand the requirements. So let's say that you are a staking protocol that wants to allow people to stake up to 1 Ethereum every transaction. So you have these requirements, you write a test without the code. So you write first the test and then you write the code. And in this test, you have the requirement of maximum 1 Ethereum per transaction. So you write a test that says, if the transaction sends me more than 1 Ethereum, this should fail. So after writing all the tests, you write the code to make the test pass, and then you see if you have to improve something, to change the requirement, or to go back to reading and understanding them. And after that, when the code is ready, you have finished. Yeah, sure.
I don't know about test-driven development, but makes it only positive tests or negative tests?
Yeah, it should be done. Tests should be done with negative tests, positive tests, covering all the edge cases and interaction for a lot of users. Yeah. There are different kinds of tests, so you could fast testing if the protocol, you think that the protocol will have a lot of money. Fast testing will probably help a lot because it will help with a lot of edge cases that will happen and negative tests. So yeah, testing should be should cover the whole code and should be done in a way that prevents a lot of logical error from happening from the edge cases. Okay, so yeah, this might be seen as boring because security is boring. If something exciting happens, it's an hack. So every time someone gets excited, they want to talk about something, it's an hack. So if you see a protocol that is not talked about in security, sometimes we talk about good protocol in security, but most of the time when we talk about security, it's about hacks. So when it's boring, it's good because it's secure. So the steps that I described earlier should be followed because if something is boring, it's very good in security. So also your code can and will be viewed by other people. So linters and formatters should be used, peer review, analysis tool, and also automated workflow in your repository could be useful. No, they're in another slides. So one of the questions could be, so if I need an audit, why doesn't the auditor do this kind of stuff? Why don't they run linters, formatters, analysis tool, automated workflows? And the answer is that auditors actually do it. So we do run those kinds of analysis tools. But number one, is the team that actually ask for the audit that will deal with the problem. So it's better to prepare first. Number two, most of those tools that I described earlier, so linters, formatters, automated workflow analysis tool, will help with readability a lot. And as auditors, it's very important to have readable code because you don't have to focus on formatting stuff. You can focus on the real problem and the real threats to the smart contract. So these are a few of badges that you can have with automated workflows. So every comment that you have on GitHub can tell you how is it going. So you have the test coverage, the percentage of test coverage, fast testing if it's passing, and various analysis too. So now we will see a few of the smart contract hacks that can happen. Wait a second, is the next slide? Yeah, okay, so I will explain a bit of the attack. Some of the attack are very nuanced, so I will talk a bit about them, but they are not comprehensive. So this is not a comprehensive list, and the explanation will not be a comprehensive explanation. We actually have on our blog at Hacken, we have many explanations for this kind of attack. So if you want to learn more, you can go on hacked.io, I think /blog, and find out more about this. So probably the most infamous attack is the reentrancy attack. Someone of you know Ethereum Classic? Have you ever heard of Ethereum Classic? Okay, so Ethereum Classic actually was born because of a reentrancy attack, and we will arrive to this in a bit. So this is one of the most devastating attacks, and can happen because there is an external call to a non-verified contract, or there is something that is called the check effect interaction pattern that is broken. So you do a transaction, you do an external call before changing a state variable. We can, this might be too technical for people that do not know code, so we can see this example. So you are contract B, and you want to withdraw funds from contract A. So you're calling the withdraw function on contract A to get back your Ethereum that you deposited. So contract A does check balance. So it sees that you have 1 Ethereum and that you should get it back. Then it sends you your funds, and as soon as the funds is sent, the fallback function is activated. So the fallback function calls again the withdraw function on contract A. So it restarts again. So it's check balance and funds and restart again. So we never reach update balance. So the balance that you should receive is always 1 Ethereum because it's never updated. This instruction should be before send funds, because in reentrancy attack you should update the state variables before doing external calls. So this is, we won't get too technical, but this is one of the most devastating attacks. To prevent it, you should only do external calls to verified contract, or use the check effect interaction pattern, or use mutex like no reentrant from OpenZeppelin. Yeah.
Was this attack that was used in Ethereum?
Yeah, in the DAO hack in June 2016, yes, this was the attack. Exactly, I don't know if these are the name of the variable, the functions, but like this was exactly the attack that was used in that moment.
Excuse me, but is this the root cause? Is a human error, or is it technological?
Technological, because so this function, this piece has the contract that you need to receive 1 Ethereum. This piece sends you the Ethereum. As soon as the Ethereum is sent, this function is activated, so it's called back again. And so this function says again, okay, 1 Ethereum to withdraw. And so it starts again and again and again, because it never reaches the point where it says,
The coder didn't.
yeah,
right?
yeah, it's the code. It's like it should be written in a way where this does not happen.
Then it was a human problem, so the programmer didn't write it correctly.
Yeah, like we can argue that every smart contract problem is human problem, because yeah, if a human write it, yeah. But this was one of the attacks that is more on the technological side than the human. There are other where like the problem is very much the human. This one was written badly, so it happened. Yeah. So this attack actually changes most of the time. This is one of the attacks that changes the most. So there was the normal reentrancy attack that happened for the DAO. So the DAO contract in June 2016 was hacked, and the foundation was kind of forced. There is like a debate about if it was forced or not to hard fork. So in August or July 2016, they hard forked and they created Ethereum Classic. That is the chain, the original Ethereum chain, the chain where it all started, and Ethereum that, as we know today, that is the chain that like we know as Ethereum. So the difference is that in Ethereum, the address of the DAO is like the address of the attacker of the DAO is blacklisted. On Ethereum Classic is not, so that's the main difference. Now also one is proof of stake, one is proof of work, but we'll not enter in the differences. But this attack changes a lot. So 6 or 7 months ago, there was discovered another type of this attack, that is the read-only reentrancy attack that was used in this hack. So it's very important to not only have audits, but also have bug bounty. We'll arrive to that, because hacking crypto can change very much. So like till 6-7 months ago, that attack was not being looked at. So most of the time, if that was present, it would not have been caught by auditors, because it was not known. It was not something that people would have looked at. So it was discovered very, very like by little time. So we can look at another one, the denial of service. So this attack, mostly this is a malfunctioning of the contract. So when denial of service happen, is because the contract cannot offer a service, a functionality, because there is either a logic error. So we can imagine a division by 0. So there is an edge case. You are, I don't know, in a math formula, you are dividing by the user that you have. You have 0 users, so the transaction will always fail. So there is a malfunction of the contract, or because you have some kind of cycle that goes through a number of variables that is too big, so it goes out of gas. So to prevent it, you should impose limits on the amount of like the range of the cycles, and you should again write tests to avoid edge cases, to have logical errors. This kind of attack is more is not really to steal stuff, but sometimes people can grieve, like can attack the contract just to make a DOS happen, just because they can. So even when there is no financial transaction involved, people might still attack the contract or your contract because it can be fun. Like it's a puzzle, you want to solve it, and that has implication on the real world because people have put money in the contract.
What was the worst case scenario?
Worst case is there is a logical error that cannot be fixed. So like if there is a withdraw function, there is a logical error that cannot be fixed, so no one can ever withdraw their money back.
Okay.
So denial of service, no people can steal money, but the functionality is stopped. There is something that is stopping it, and so if like the worst case is people lose money that way.
Okay. So basically the only way is to make the corrections in the smart contract, but if there's ongoing
sometimes in smart contracts are immutable, but sometimes they have setter function and they are upgradable. So there are some kinds of some part of the smart contract that can be fixed. So sometimes the logical error that happens can be fixed with a setter function. So you can change some parameters and fix the error. Other times it's just hard-coded, is like it should be like this, and since they did not write tests, they don't know that that's an edge case that can happen. So sometimes it's not fixable. Sometimes the error is there, and
so it's possible to deploy the correction mitigate.
Sometimes yes, others no. It depends on the code, because if there is like a function that allows it to change, yes. Otherwise, if it's hard-coded, no, it's there. It's impossible to change it. So we can see another. Actually, I don't know if we have time. Yeah. Let's look at it. So there are. This is not a comprehensive list, but we are looking at a few of attacks. They are very different. So the first one was a very famous attack. Was something that probably developers look at when they write code. The second one also, but it's very tricky sometimes to spot. This one is something that I've seen people know, but it's mostly unknown. So like a few developers didn't know that this was a problem. So this is the transaction origin, authorization via transaction origin. So transaction origin is a global variable that tells smart contract who is the original sender of a transaction. So you can call a smart contract, and a smart contract can continue to call other smart contracts, and the transaction origin will always stay the same because that's the starter, the externally owned address that started the transaction. So if you do actually authorization via transaction origin, you can have various kinds of phishing attacks, because people will fake being the final smart contract, make you call the middleman, and actually call with your transaction the final smart contract. So if you use authorization via transaction origin, you can, since it's the original sender of the transaction, the authorization will go through because you called a smart contract that called another one, but transaction origin is the same. So this is a kind of attack that I don't see very often, but when I see it, developers don't really know that it's there. So how to prevent it? There are various ways. The main way is not to use it. So just use, there is another global variable that is called message sender that is a bit different, but in some ways works in the same. So just use message sender most of the time, don't use transaction origin, and all the problem will be solved. There are cases where transaction origin can be used, and so it should not, transfers to verified contract should not be done. You should check other stuff, but most of the time just don't use it, and you will solve the problem. Okay, so let's talk about flash loan. This is probably the most interesting attack, because every time you look at a flash loan, it's different from another case. So if you Google flash loan hacks, you might have a list. If you look at the explanation of all those flash loans, they're all different. And it's very interesting to watch, and it's very actually fun to find them in the code, because you have to think like very hard of how can you break that code, because flash loans are almost never obvious. You have to think in a lot of ways of how you can actually break the smart contract. Do you know what flash loans are? Okay, so I will explain for the one that have not raised their hand. So flash loan is a kind of financial instrument that is possible only in crypto. It's a loan that is not collateralized, so you can ask this loan, and there are two conditions to this loan. The first one is that you have to repay it back in the same block that you ask it. So if you ask it at block 10, you have to repay it back at block 10. The second condition is that most of the time there is a fee, so you have to repay, I don't know, 10 million from the flash loan and 2% fee on top of that. So if you qualify for those two parameters, you can ask for the flash loan. So you don't have to put up collateral, you don't have to do anything. You respect those two conditions and you can go on. Flash loan per se are not bad, so they can be used for arbitrages, and they are actually an instrument in DeFi, but they can be used in a malicious way because they allow you to access, I don't know, depending on where you ask the flash loan, millions and millions of dollars in different tokens. So if you have some check that depends on the amount of token or some price on DEXs, that can be easily manipulated with a flash loan. So for most protocols that use that need to have precise prices, they need to use an oracle, because otherwise if you use price on chain, it can be used easily be changed for one block with a flash loan, and you get attacked and they pay back the fee with your funds. So flash loans are very complex and can vary all the time, but there are a few things that you can do to protect yourself. One of the things is actually doing audits, because this is probably the attack that I see less understood by developer, because you having externalized that look at your code and try to understand what is going on and how you can break the code is very important. So yeah, flash loan attacks are very complex and can vary all the time. So let's talk a bit about the different kinds of external reviews. So there is audits, bug bounty, and penetration testing. So a combination of the three might be good. All three is perfect. So if you have all these three kind of external review, it's very good for your project. We will explain now why. What are the differences? So why you should need an audit? Audits are most of the time done before the deployment, and the deployment, as said earlier, is most of the time immutable. So if you deploy something, you can change some parameters. You might be able to change a bit of the logic of the smart contract if the smart contract is upgradable, but most of the business logic is set in stone. So it's immutable, and you should get it right first, because otherwise you will either get an hack or you will need to redeploy, and that's never good. So utilizing audits is very important because of the immutability status of smart contracts, and having externalized that actually are like the career of auditor is identifying risk and knowing how to solve them is very important, because they can help detect issue, or even if there are no issues, sometimes we help with optimization, so with gas optimization or with a bit of the design of the protocol. So what does a security audit do? A system overview. So we read the documentation, we read an aspect, we read the user stories, tokenomics, everything that there is to understand the system. We do a security analysis, run automated tools, and do a line-by-line code review. The line-by-line is actually the most important parts after you understand what the code is doing. Automated tools are sometimes useful, but most of the time they don't give you really important stuff. So if you have done everything that we said earlier, the audit will be very easy, because you already have a comprehensive review of your project, you have functional requirements, you have the technical overview of your project, and you have unit tests. So you just need to maybe prepare those things a little bit more and assign a responsible person to talk with auditors. But if you followed all the steps, the audit will actually be very fast. Sometimes the audit can take months. If you go on our site, you can see that some audits have the timeline, and they can take even up to 5-6 months, because those steps were not followed. So the score for the security score was very low, so they had to take time to understand their project, writing the documentation, so it took a long time. So those were the audits, and they are very important. Another important piece of security is bug bounty. So the difference there is that audits are done pre-deployment, bug bounty are done after the deployment. Audits are mostly done by centralized entities. So like at Hacken, we do audits because we put our name into the audit. So we say, we looked at the code, so if you trust us, you should trust the code. Bug bounties are more decentralized, so you can be anonymous. You just need to look at the code and find for vulnerabilities. And with the audit, it doesn't matter how many vulnerabilities are found. You pay the same. With bug bounty, you pay only if vulnerabilities are found. Both of them together, because as we saw earlier with the reentrancy attack, there was one kind of reentrancy that was not being looked at. So the audit is a snapshot in time. So the audit is like, in this moment, this smart contract is secure. If anything in the smart contract changes, or the security landscape changes, this smart contract is not secure anymore. So bug bounty help with that, because since they are after the deployment and they are continuous, if some new vulnerability arise, you will possibly catch them with bug bounties. Sometimes when someone finds a bug, they don't report it, they just use it to steal money. But if you have a bug bounty, there is the possibility that you will actually catch it before the bad guys. So then there is the penetration testing that is for everything that is not Web3. So for the database, for the website, for every part of the infrastructure that is not a smart contract. So if you have if you have a bridge, you need to have a centralized part. So you need to check if you have open APIs, if you have the database that is accessible. So the keys might get stolen that way. So it's also important in some projects to have the penetration testing. So after that, after doing all these steps, you will have security, stability, and data integrity, and you will gain confidence and community and investor trust. So if you have any question, you can find us on hacken.io or me on those socials. Thank you. Yeah.
I was about to just ask, how do you see this? I guess there's, in principle, not much difference to general, system security approaches when it comes to this kind of a more administration level of security. I mean, I'm thinking about some ISO, methodologics and.
The point is that it's very hard to do a standard like ISO because the security landscape changes so fast that it's very hard to standardize something that changes so fast. So I'm also a CCSSA auditor. That is like a kind of standard for how to keep your private key, but that can change very fast if there are updates to how private keys are generated, or if we understand that something in the cryptography might be wrong. So the landscape changes so fast that it's very hard to do standardization on this.
What I meant is that kind of the best practices around the actual of the smart contract technology is relatively
it's similar. The main point is that this is immutable and money are always connected to it. So in the general way, security sometimes can be a bit overlooked. In this, like in Web3, cannot be overlooked because you will get attacked. Yeah.
Maybe this is a follow-up. So, I mean, what is the result of the security audit? Is there like a certificate that you...
Yes, we most of the firm do it, but I can speak for Hacken. We do all those stuff. We also do a little other, a few more stuff to really make sure that the smart contract works perfectly. So we try to break the tests. So sometimes tests that are not very good arrive. So we try to break them to understand if the code is tested. So we do a lot of stuff, and in the end the result is a report where we say the vulnerability is here. You have this way, like you might have one or more ways of how to fix it. So we explain what are the risks with the protocol, we explain the vulnerabilities and how to fix them.
And then you, after this implemented the fix, you retest it?
Yes, we personally, this will vary dramatically from firm to firm. So we personally have something that is a middle stage called remediation. So we do the first audit, and then there is the first remediation that if you do it in 10 business days is free, so we give the possibility to change the code fast and give it to us. If you didn't do too much mistakes, you will actually do it in the first 10 days and have the remediation free. We'll look at the code again and give you again a report. Sometimes they solve something and add other problems, so we have to report them too, and then it continues. Most of the time on the second or third remediation the audit is finished. Sometimes if the team was really not prepared, it can arrive to 6, 7, 8, and those are the audits that can last months.
And in the perfect case scenario then, let's say you do this and there is a certificate and then nothing changes and there is an actual problem, issue. Do you have any liabilities for that?
No, there is, I actually don't know the legal part of that, but there is a disclaimer that says that we do everything in our power to try to look at the code. So mostly it's not something of a liability by in legal terms, is something of a trust for us. So we have been we have audited code that has been hacked 3 times in the last 5 years that Hacken has been alive. 5, 6 years, and we have done, I think, 1,500 audits. So the ratio is pretty good. Sometimes something can slip up, but if you should see at the amount of audit that has been done, the amount of hack that actually happened, and that's the trust that you put into the auditors, because I don't think anyone puts as legal liabilities if something happens.
Are you, for example, familiar with Hacken? You can speak on Hacken's behalf. Are you submitting also some kind of bugs or vulnerabilities to Ethereum Foundation and community?
Me personally, no. So I'm only. We don't do it. We have not done it to the Ethereum Foundation. So we have a department that is for auditing L1, and actually there was a big news. There is my coworker, it's called Bartosz, found a problem in the zero knowledge proof of Binance. So that was a big news because the zero knowledge proof of Binance was broken. So sometimes, yeah, that happens. So if you have free time from work, that doesn't happen often, you can look at other code and submit also bugs to Bug Bounty. This doesn't happen often, so if it's not a client, we might not have time to look at those kinds of stuff. So in this case, Binance was not a client. Bartosz just took a weekend and said, okay, I want to break this, and he actually broke it. It's everything? No more question? Okay.
The last question. I wonder how did you get access to the Ethereum mandate? Do you or your corporation owns a node of the Ethereum mandate?
No, we don't have nodes. If smart contract is verified, you can go on sites like Etherscan, and you can actually look at the smart contract, you can look at the code. For us, actually, the code arrived from the team, so the team sends us their GitHub and tells us this is our code. But if you want to look at projects, you can just go on Etherscan, and there will be the code, and you can look at it. So you don't need to have a node. A node is depending on the type of node, but a node is something that actually verifies that the chain is working properly, but you don't need a node to access the mainnet.
So I know that you only did the or your main is the semantic analysis, not running the execution of the code.
Sorry, I didn't understand.
So I mean, as your analysis on the attacks on security issues mainly based on semantic analysis instead of the execution of the code. the execution result of the code?
No, many attacks are based on the execution of the code, not on external factors.
So there's no need to get the transaction records or to get execution records of a post-transaction interaction.
No, that's another branch of security that's called on-chain analysis, and that's totally another world. So there can be many ways of doing on-chain analysis, but no, we don't do that. We don't look at transaction. We just look at the code. Most of the time, when we look at the code, it's not on the blockchain yet, so it will be put after the audit. Yeah, perfect. Thank you, everyone. Thank you.